Ladies and gentlemen, from the firehouse in North Manchester, Indiana, it's Good Night with Christopher Blue. Now here's your host, Christopher Blue.
Hello and welcome to Good Night with Christopher Blue. I'm Christopher Blue, and we have a little bit of a different show for you tonight. Tonight, we were supposed to have Professor Promethium come back out and show us some awesome science like he did last time. However, he couldn't quite make it. Aww. Sad, I know. However, he reassured me that he had recorded himself doing some awesome science experiments outside of the show. So, take it away, Professor Promethium.
Hi everyone, and thank you for joining me for science today. Today we're going to talk about something I bet you've thought of at least once in your life, and that is, why do some things float and some things sink? Now I bet some of you who are listening think that you know the answer. You're like, well obviously some things are heavier than other things. You're on the right track with that thinking, but I want you to think a moment. Imagine you are at a swimming pool and you have a penny. And you drop that penny into the water. What's going to happen to that penny? It's going to sink, right? But what about you? What if you're just laying on top of that water? Most humans will float on top of that water even though you weigh a lot more than that penny does. So weight isn't the complete answer to this question. The question for why some things float has to do with this thing called density. Density is kind of a big sciencey word, but density is talking about how much stuff is crammed into a certain amount of space. So when you're talking about a human or a penny has more stuff crammed into a smaller amount of space than you as a person. You as a human, you're more spread out. The stuff that makes up you, the matter, is more spread out than the matter that makes up this penny. And so if the matter that makes up you is more spread out or less dense than, say, the water that you are floating on, you're going to be floating. If the matter that makes up you is more dense or more compact, you're going to sink. Now, to show that, you can test many different things at your house. I have a few things in front of me here. Like I have some cork. Cork is very good at floating on top of water, right? You can test different coins like pennies, even some rocks you find outside. I have a type of rock here called scoria. When you first pick it up, the first thing I notice is my brain is a little tricked out with this. It feels lighter than my brain thinks it should be. That's a good indicator that what you're holding is less dense than normal. So let's see what happens with this rock. We can see we even have a rock that's floating in the water here. Now that's really cool, but I'm going to show you all an activity that you can do at home with everyday objects. What I have here is I have an empty water bottle, some water that I put some blue food coloring in, and some oil. We're going to make what I like to call a density tower that will show us the order of density of these materials here. So the first thing I'm going to do is I'm going to carefully pour in the water into my bottle here. I'm only aiming for maybe halfway full. So right now we just have water in here. Now we're going to see what happens when I pour oil onto the water. Now some of you might know off the top of your head that oil and water, they're not going to want to mix together. We're just going to see what happens when I pour the oil in here. Those of you who thought that, you're absolutely right. Oil and water do not like to mix together, and you will see we have the yellow oil sitting on top of our blue water. It does not want to mix together. But we're going to see what happens when we put in some other things around the house. And we're going to see where it falls in this density here. So I have a penny. If you guess what's going to happen with the penny, it just falls straight down through both the oil and the water. So right now the penny is the most dense out of these three things. Next thing I'm going to put in is a little Lego brick here. Some of you who play around with these might have an idea what that will do. See, we have it floating on top of our oil here. I think there might be a little air bubble in there. Let's see if we can get that out. Air likes to change the density of things. All right, now it's just hanging on top of there. But let's see what happens when we put that cork in there. And that floats on top too. Now, the fun thing about density is all these densities, the densities won't change. So even if I take my bottle and I mix everything all up, for a few seconds, it's going to be all mixed up here. But if I just let it hang out for a minute, you'll start seeing these things will start to go in their natural order. You let the bubbles kind of settle. You'll see the water goes back down to the bottom and the oil back up at the top. And now that we've kind of mixed it around, we're kind of seeing what the Lego truly wants to do. The Lego is a little bit more dense than the oil, but less dense than the water. So the Lego brick will like to float on the water, but sink in the oil. So long as you've got the cap on here tight, you can keep mixing it up all over again. And each time you do it, everything will still even out to the way they're supposed to be. And that's a good way for you to learn the densities of different objects. Hi everyone, it's Mr. Rupert. I am here with a science experiment that everyone can do at home with just a few materials. Today we're going to make volcanoes using chemistry. To make volcanoes, really you just need a container to make your volcano in. I like these yogurt containers because they're a good volcano shape. You need some baking soda, which I have here in my cup, some vinegar, and some soap. You might understand how the baking soda and vinegar are going to work, but you might be a little confused about the soap, but we'll get to the soap here. We're going to use chemistry to make two different kinds of lava with our volcanoes. There's really two different types of lava in nature. The first kind is called and that is fast-moving lava. The second kind of lava is called pahoehoe, and that's slow-moving lava. With this experiment, you can make both types, and I want to show you how to do that. So the first thing you will need is to take a couple, 2 or 3 would work, scoops of baking soda, and put them in your cup you're going to make your volcano with here. You can use bigger scoops if you want. If you have food coloring at home, now would be the time to put some food coloring in there if you want to make like your lava red. I don't have any food coloring here at my house. But then after this, you're just going to add a little bit of baking soda, and then you should see the baking soda and vinegar react together. And they'll start to make bubbles that will then rise out of your volcano, if I pour enough in here, making your fast-moving lava. Because that happened pretty fast, right? Now I'm going to step to the side and dump this stuff out so I can start it again. Alright. Now we're going to do that again, but now we're going to try and make it slow-moving lava. We're going to try and make that pahoehoe lava. So you'll probably still have some baking soda that didn't react with the vinegar after you dump it out a second time. So you might not need to add as much baking soda again. Now this time, before you add the vinegar, you're going to add a little drizzle of Dawn dish soap inside your volcano. Now what happens is the baking soda and vinegar react together and they make a gas called carbon dioxide, which makes all those bubbles you saw. Now hopefully what will happen with my Dawn dish soap here is when that reaction happens, the Dawn dish soap will kind of trap those bubbles. They won't let them pop and escape as fast, and because those bubbles are trapped, it should make it happen a lot slower this time. So let's add our vinegar and see what happens. We should see a reaction that happens a lot slower this time. The bubbles are kind of getting trapped in the Dawn dish soap there, so they're not escaping as fast. And we should have a reaction that is happening a lot slower, representing our slow-moving pahoehoe lava. Now this is a science experiment, like I said, that you can perform at home. Just as long as you have baking soda, vinegar, and some soap, you can make your very own volcanoes at home. Today we're going to talk a little bit about the weather. Now the weather can do lots of really weird stuff and sometimes seems a little bit mysterious, but there's really 3 things that makes the weather happen, or that drives the weather. So the first thing you need is you need air. Air's all around us. Earth has plenty of air. Second thing you need is heat. Now if you think for a minute, I bet you can think where Earth gets most of its heat from. And I bet you're right, it is the sun. So the sun gives Earth the second thing it needs for weather. It needs the heat. And the third thing Earth needs for weather is water. Earth has a lot of water in our oceans, our rivers, our lakes. Now, all 3 of those things can get all jumbled up, make a whole bunch of different types of weather happen. But I have a few experiments that you can do at home to show you these different parts of the weather, and you can make your own weather. The first one is really easy. We're going to make weather in a bag. The first thing you'll need is a Ziploc bag here. I drew like a scene on mine, representing like a house and a tree. And then you'll need to fill it up about 1/3 of the way with water. Now make sure you zip up your Ziploc bag, making sure that there is some air in there. And next thing you have your air, you have your water, and then you need that heat. So if you want to take your Ziploc bag and tape it on a window in your house that gets plenty of sunlight, and if you check back throughout the day, you'll start to see sometimes it gets foggy in that bag. The fogginess is clouds. Clouds will be forming inside of your bag. If you come back later, you might see streaks of water starting to fall down the sides of your bag. And if you see that, it's raining inside of your bag. So if you just have a Ziploc bag and some water, tape it to your window, you can make your very own weather in a bag. Now, sometimes, especially here in Indiana, we can get some crazy, kind of scary weather in the form of tornadoes. That happens when you have like your low pressure air and your high pressure air, or your hot and cold airs that kind of get all jumbled up, makes a lot of wind, makes some tornadoes. Those can be kind of scary when they happen in nature, but we're going to make our very own tornado at home, and you can do this at home. All you'll need are 2 large bottles, lots of times soda comes in these, and a way to connect them together. Now, I have this neat little connector thing to connect my bottles together, but if you don't, you can connect yours with just a washer and some tape. If you just set the washer on top of one of the bottles to make that hole smaller, and then you put your other bottle on top and tape it all together, you can make your very own connector for your own bottles. Just make sure you use plenty of tape, because the next thing you'll need is some water inside of one of your bottles. I like to fill mine almost halfway up with water. That should be plenty of water. And once you connect your 2 bottles together, secure, either with a special connector you can buy at a store or the one you made at home. Once it's connected here, we're going to tip our bottle upside down and give it a little swirl. And then if you just let it go, you'll see we've made our very own tornado inside of our bottle. Lots of the same things are happening inside your bottle that are happening in real life with real tornadoes, but it's a little less scary when we see them happen this way. Now this has all just been a little bit about what makes the weather happen and some experiments you can do at home. I hope you enjoy me with our science activities today, and I hope you have a great rest of your day.
That was some awesome science. Thank you again, Professor, for recording those and sending them in. Hopefully we can actually get you on the show again sometime soon. Well, that's our show. Thank you guys so much for liking, commenting, sharing, and subscribing. And don't forget to ring that bell so you get notified whenever we upload new content. Until next time, good night, my sweet baby angels. I'll see you tomorrow.